Hello class, today I'm going to show you how we can extract the maximum jet height for your project without manually extracting all the dimensions. I Probably there are many other methods. I found one method which may be useful. As you can see, this is the geometry we have. It's a half of the geometry, so this left side is going to be our symmetry line, and we have our inlet at this bottom, very small bottom here, and we very large enclosure. So you're familiar with this domain, how we fix the different parts, what type of it's a transient simulation. You need to include model, the setting for model, material, cell zone, everything, boundary conditions. I'm not going to deal with those details. Let's go how we can extract the data when we have the intrusion here and we just want to see the maximum height. So to do that, I first created Isosurface. As you can see, inside the results tab, you have this surface option. You can create partition, zone, imprint, point, line, Isosurface, and other stuff. One of them is Isosurface, which is going to be useful for us. I could use line or Isosurface, doesn't matter. So what I did is I decided to say show me mesh in x direction to be value of 0. So ISO value of 0 in x direction for all the meshes. So it is going to be vertical line at symmetry. So basically, when I generate this, because it says give me all the mesh with x of 0, so x0 is here, and all the mesh here is going to be a part of this Isosurface. So with this definition, I created one Isosurface at this side, which is the line I want to sweep to get the height of the intrusion. So I did this and I named it symmetry line. So this line, you could draw a line simply if you know the dimensions of this line. I didn't know, so I just lazy. I just defined where is 0. So give me all the mesh on the 0. Okay. So this is my first Isosurface. The second Isosurface I created was for the temperature, because when you want to say this is the maximum height of intrusion, you need to have a criteria. For example, if the domain temperature is 300 Kelvin, you can say, okay, 99% of that temperature is going to be my criteria, or 98% is going to be my criteria. Whatever is that your criteria, you need to create Isosurface for that criteria. So for this simulation, I just used 300 Kelvin as a domain temperature. So I decided to go 998 as my breaking point to decide this is the height of the jet, upward jet. So as you can see here, static temperature 998 is that Isosurface for that temperature. So how I did it, I first named it, then I selected temperature here, and the value for ISO was 998. You could select 999. It's your choice, and you just need to define for example, the height I found is based on this criteria of this temperature. So using this definition, I created another isosurface, which you can see here. Now, up to this stage, I have vertical line and definition of isosurface, which is basically it's just giving me where I have the temperature of 998. Okay, then I defined a report definition. I made it height here. So as you can see here, for the surface report definition, what I did is first I named it any name you want. I made it height because it's going to extract height for me, and I said okay, let me go back to the isosurface. I made a mistake when I define temperature for 998. I asked to find that temperature at my symmetry line, which I defined here, this vertical line. So not everywhere, just isosurface on that line. So when I create, it's going to be the only on the created line I created to get that specific temperature. Okay, let's go back to the report definition. So you define a report, and facet, maximum, minimum, average doesn't matter. You select facet and ask ANSYS, give me mesh. The field is going to be mesh. In what coordinate? I want to give me y coordinate of the mesh, which I have static temperature of 998, which I already defined, and I know this is the temperature of 998 over that line, and report this one. So after that, I went and asked, I right click new, and I asked for extracting those reports because I need to have time and height. So height was, height was here, so I asked to move this side. So I had flow time as a default, as a time, and height, which is here, I already defined at the report definition, and they are going to be reported inside the file named here report def 30 r file out. And for every time step, you could change the time step whatever you want. So by this procedure, you can automatically extract the data you want for the height of the jet. So let me show you what I did. I did just very short simulation. As you can see, starts with this very short part, and a small flow comes in, gradually grows, and this is my final simulation. I simulated up to this stage, not more. So as you can see, we gradually height increases. Let's go for the first one, and I draw a line here. Let me turn off this. I draw this line, yellow line here, as you can see here, this vertical line, and then I draw a chart to extract. X is going to be my y direction here, and y is going to be temperature, because I want to see what's happening and apply. So for the first time step I extracted, this is the temperature profile I have. So if I and I expected my simulation to extract this point or close to this point, because I decided to be 998, so it is going to be a little bit lower than this. So it should be 0.1, something like that, because this is 0.1, 0.05, so 0.01 maybe, something like that. And as time step grows, this is going to grow, and for my final one, this height is going to be almost 0.05 here, mid. So let's go back to the data we have. This is my simulation data. You need to find the output I showed you here. Where is the, so it's going to be report def 3 zeros. Okay, let's find that. So here, this is not here, run, yeah, here. So this is the file we have for those data. The format is .out, but you can make it and open it in any text editor. So you can see this is the data I got. This one is the time, and this one is height. As you can see, start from 0.01, which we saw in the here for the first time step. The height is almost here, so it's going to be 0.01. Good, great. And for the last time step I extracted, which is 5.5, is 0.048, almost 0.05. So if I go back here and show you this, and it's here, so almost at the center, which is pretty good. It shows my solution to automatically extract the data works. Okay, I hope it helped. Sorry for the late preparation of this video. I just learned this and wanted to share with you. Okay, good luck.